I'm Doug Lichtman.
And I'm Elliot Lichtman.
And in this video, we sketch a challenge that builds on our prior work on checksums.
To get started, remember that a checksum can help us catch any single error in a line of digits.
For instance, if we wanted to send the digits 4, 7, 8, 2, we would add 4 plus 7 plus 8 plus 2 and get 21. So we would put a 1 at the end of the transmission, sending 4, 7, 8, 2, 1.
Now, when another computer receives that message, the computer can check the math. If any of the digits got corrupted, the checksum wouldn't match. For instance, if that 8 came through as a 0 or a 2 or anything other than an 8, the checksum would not match to 1.
And all that is great if you have only one error to detect. But what if you have 2 errors in a string of numbers?
A book we've been reading proposes a strategy that we thought pretty cool. It's called a staircase checksum.
Suppose we're trying to send the number 4, 6, 7, 5, 6. First, we would calculate and send the normal simple checksum. So 4 plus 6 is 10, plus 7 is 17, plus 5 is 22, plus 6 is 28. So we would add an 8 to the message.
Now for the staircase. We take the first digit and multiply by 1, the second digit and multiply by 2, the third and multiply by 3, and so on.
Here, that gives us 4 times 1, plus 6 times 2, plus 7 times 3, plus 5 times 4, plus 6 times 5. And if you add all that up, you get 87. And so the staircase checksum would just be the ones digit, the 7.
The big idea here is that if you send both the normal, simple checksum and the staircase checksum, you can catch 0, 1, or 2 errors in the message.
Let's show you how. Try an example with just one error. Suppose we send a 1 instead of that 4. A 1 followed by 6, 7, 5, 6. You know that our normal checksum would catch it, and so there, no worries. We'd catch a single mistake.
Now, try 2 errors. Say 1, 5, 7, 5, 6. The normal checksum adds up to a 4, so that's another easy one.
Okay, now the really cool example. Let's again have 2 mistakes. The first digit is a 2, not a 4. The second digit is an 8, not a 6, and then 7, 5, 6. The normal checksum is 8, so it would not catch the problem. The first digit went down by 2, the second digit went up by 2, and so the normal checksum is tricked. Those mistakes cancel out. But now, watch the staircase.
2 times 1 is 2, 8 times 2 is 16, 7 times 3 is 21, 5 times 4 is 20, and 6 times 5 is 30. The sum there gives us 89, so the staircase checksum is 9, and we know there's a problem.
All right then, so here's your coding challenge. Ellie and I want to know if this strategy really works. That is, can we take any 5-digit number, calculate the regular checksum, and also the staircase checksum, and then catch every possible 2-digit mistake?
You can write code to answer this question. Have Python ask for a 5-digit number, have it calculate the 2 checksums, then have Python generate every possible 2-digit mistake. Calculate those checksums and make sure the mistaken checksums are different from the original checksums.
If you test every possible 2-digit mistake, and all of them generate checksums that differ from the original pair, then we've got it. We've got a strategy that works.
But if you can find any example where there are 2 mistakes but the checksums still match, then we know that the staircase checksum is a flop. It can't reliably catch 2-digit mistakes.